Okay, so we'll be talking about classes and objects today, and classes and objects. So, a class, if you've worked with any programming language that is not functional, I think okay, even JavaScript that is mainly functional focused is also doing this. Is like a blueprint. A class is like a blueprint where you have a collection of informations about a specific item, right? So if you want to replicate any real world object or real world item using your code, a class is like your blueprints. So for example, when you want to, or if you worked in a factory, if they want to build anything, they have something like a mold that is already there, right? Let's say um for example, bread factory. Now they have like a mold that is there already, that is used to make bread, different types of bread and all. So that's what a class represents in our own instance. It is not the actual thing, but it is what we use, the blueprint that we use to make a bread that looks this certain way. If you want to make like a cake, there are things, of course, there are things you have to mix up indeed, but that thing that holds it together until it forms a cake is what's in our instance that we can liken to a class. I don't know if it makes sense.
Yeah, yeah.
Okay, so that's it for it's just a blueprint that we use to define a real world object, right? So a class has different things. It has methods, which we already know, which is the behavior of a class, and it also has attributes, which can be the variables that is defined in the class. Those are the things that a class can have. So, and we've been using classes all this while. uh, in Java. Anything you are doing in Java, you are using a class to do it. But we're not paying attention to some of those things. This class is what will help us pay attention to that. So how do we define a class? If we're not using what's it called? IntelliJ, if we are using something like VS Code or maybe other notepad to define our classes, it would be different. You create a file, and your file has to be the same name with your class, the class you are defining, you are creating in Java. So, but in this case now, we just say the name of the class. It's IntelliJ creates that file for us using the same name. So, for example, let's use a car aspect. Let's use a car as our
Ebuka, please,
example.
can you repeat this thing you just said? If you
Okay,
said if you are using something like a VS Code.
VS Code. Yes, the name of your class, the name of your class has to be the same with the name of the file that you are creating.
Okay, okay.
Yeah. So that's just it. So of course, this is our assessor, and this is a keyword that says, "Oh, we are creating a class." So, and then this is the name of the class. Does it make sense?
Yes.
And like I said, a class usually have two things. A class has attributes. Let's say attributes, and also behaviors, which is also known as methods or functions in some cases, but in Java it's called methods. So those are the two things that a class have. And in our defining our this thing in a class, we will use our assessors to start to say, okay, we want this to be this kind of level. Generally, it is advised and it's also the best practice to start defining your attributes of a class with private keyword. So, and followed by your data type, and the name of the attributes. Why it's important to do this is because a good programming language, you don't want outside people that is outside to just have a direct access to this guy to modify it. You don't want them to just say maybe class class.name or something and set it for you without having to use the method that you've defined. Someone can just be passing values here and then your code will become buggy. You don't even know where it's coming from. That's why you need to have an assessor. There are some cases you might want to use a private, a protected or public. There are some cases you do that, but that is not like, will I say, it is not a class. In case where you use a public, you are just using this class to house other informations. So you might need, you might use something like public static. Then let's say public static. When you are storing some information that you want to reuse, you can have a class like this. Maybe you can call it a util class or something. Then it gives you that returns the name of your app or something. Let's say app name. Let me just say app name. In that instance, you will have to have it defined, the name of your app, name of app application. This is just an example, public static, I think. And then it's also advised that you make it final, so nobody would be able to change anything that you've set here, right? In this case, this is not like the blueprint of an object. In this case, this is just a util class. This is called a util class that you are using to make or to create other things, just to avoid you having to type. Maybe you are using this app name in like 6 places to avoid you having to type name of your application in all those 6 places. In case tomorrow they now say, oh, our app name is Ebuka and Sons Nigeria Limited, right? And then tomorrow they now say, no, we are making changes in our application. Now it's going to be Emmanuel and this person and Sons Nigeria Limited. You will now go to all those 6 places or 10 places and start changing it. To avoid mistake, you just do this kind of stuff here and pass the name of the application. So when you come back and they say 2 years later they want to change the name of the application, this is just an example, right? You just come here, change the name of the application and move on with your life. You are sure that once you change it here, any place that it's being called, it will now have to return this. And being final, it will not allow you to assign a different name to it anywhere else. If you want to make changes, you have to come back to this place, make changes, and then every other place you are using it, it reflects it. So that's a type of class that we would also look into. A util class, how to utilize a util class in our application. So that's just that. Then what are the things a car should have? It has a color, it has a brand. Oh, why am I using public again? So if it's not a util class, it's not advised that you use public, please, private. Then a car has a year it was made. It has a year it was made, and what else? It has a model, yeah. Okay, yeah, it was made. Is it the same thing as the model? I don't know. No, it's not. So it should be a string. Let's just keep it simple this way. So these are the attributes of this our class. Someone wanted to say something. Do you have a question, or you just wanted to make suggestions?
No, you're asking of properties. So I was like a brand, like the brand.
Oh, yeah. Brand is the same thing as model, yeah? No,
Yeah,
it's not.
No,
It's
it's
not,
not.
yeah,
Yeah.
because
Yeah.
it's different because Mercedes, I think Mercedes is a brand and there are different models of
Okay,
Mercedes.
model. True.
Yes, so yeah, I think this is fine. We'll just keep it simple for today. Then there are different attributes we can have. Number one, there's something called a constructor. I think I mentioned it in one of our classes. I can't remember. So we have something called a constructor. It's not a method. It is how do I define a constructor to you guys now? It is how we pass values, so to say. It is one of the ways that we pass values on creation. Number one thing you need to know is on default, Java creates a constructor for you. It creates an empty constructor. So let's take, for example, now, let me just create let me create a main class here. And we take, for example, we want to create object of our class in this main class. So of our car, rather. Car. So this is your constructor. So in Java, it has created it under the hood for you by default. Now, if you want to now enforce that you want, when someone is creating this object of a class on the go, there are some things you want the person to pass. Like when you want to create object of this is object of a class. When you want to create an object of a class, you want to enforce that the person must pass some informations to you. That is when you can now create your own constructor here. For example, we can decide that we want someone to, when they want to create a class, we want them to pass maybe just the name, right? We'll just say string. I don't want all those things that it's telling me. String name. We just want the name, right? And you see, this thing is now pointing that there is an error somewhere, because here we are creating this object without object of a class without passing a name to it. So let's say name of the car is I don't know, Cybertruck. Yes, that's a good example. So it's now okay. It now takes it, right? If we now say car.name, it gives us this name because it's enforced that we must pass a name. If we add the other field variables, it will also demand that we do the same thing. We make that changes here. So this is called a constructor. Constructor. Right? Okay, so here we are saying that this name that they pass here, the name that this person is passing, map it to this name that is here. So this keyword is used to point back to the class name, the field that is called name. Do you understand?
Yes, yes.
Okay. Does it make sense, or is it confusing, or is there anything that you need to clarify?
Yeah,
You see, when
sense.
okay, if you are using IntelliJ, you press Control, and on any name, on any variable, anything, it takes you back to where the source of that variable. So this guy here, if I do this, it takes me back to this one, right? If I do on this one, it takes me back to this other guy, because even though they have the same name, it is not pointing to the same information. They are not pointing to the same variable. This guy is pointing to the constructor variable or parameters. This other one is pointing to our class attributes. So this keyword is what you use for when you want to say that the one I am referring to, the name I am referring to here, is the one that belongs to this class. Does it make sense?
Yep.
Okay. So there are different methods that we can create for this class. We can create a method that is used to create the name of the class, do the same. Like if you even do, I think it's alt insert. I don't know. Let me just generate. Yeah, it's alt insert actually.
Hello,
So
Ebuka, please. If we decide to add another attribute to this constructor, how do we do it? Let's say you want to add the brand also.
you just string brand. You just do a comma, then
Oh,
you come here
okay.
and say this dot brand equals to this. Then you will not have to go back and pass the brand.
Okay.
Yeah. So let's remove it now. Okay, so there are methods that is used or is the best way to pass values into these guys. It's called setters. So there are two types of methods that we need. We need a getter method and setter method and a getter method. So a setter method is used to pass value into the class attributes. Then a getter method is used to retrieve the value, just like their name implies. It's used to retrieve the value. So we can decide to have for all of them or for one or two. So for now, let's do everything. So we can just for now comment this guy out just temporarily. And in that case, we don't need it here again. So if we want to set the name of this class, instead of coming direct and saying passing the name here, we'll just use this guy. That is when we go into the 4 pillars of OOP, we would look into all those guys. Right? When we go into the 4 pillars of OOP, we look into why it's like that. So for now, let's just create all the values that is here. So we'll come here. Number one, for you to create an object of a class, you need this new keyword. It's a keyword. So you just do car. This name can be anything. We can decide to call it Tesla. And then it can be anything. And then go ahead. And so we do Tesla dot set brand. The brand is Tesla, of course. Then Tesla dot set color. No, I like black. Then Tesla dot set year. You set your year. Tesla dot set model. Tesla dot set model. Oh, okay. I think there is one they call Tesla M whatever. I don't know. Is anyone familiar with Tesla this thing?
Okay.
I think there is one they call Tesla M something. Let me see. Yeah, Model S. Yeah, Model Y. Yeah.
Okay.
Oh, Cybertruck is actually a model. Okay, not a name. Good to know. So we come here and we say test Model Y, right? What other attributes are we missing out on? 1, 2, 3, 4. How many do we have? 1. Have I not set name? Oh, interesting. Tesla does set name. Name is Tesla. Okay. So what is the benefit of using classes when we are doing let me just do this in Tesla. What is the benefit of using classes when we are building our code? It's to help us have create an object without interfering with a different one. So we have a Tesla here now. We can decide to have another car here. Say Toyota. What's the new car? We can set all those values, everything, the color, the year. Oops. Toyota. Set model. This is not model. And is that all? 1, 2, 3, 4, 5. Yeah. And so we'll print it. Well, now we do matrix like this. Yeah. So we have all these informations. If we access, even if we call this one here, down here, so we say we call Tesla down here, it will still give us the information of Tesla, even though we have created another car object. That's one of the things that classes help us do. It doesn't interfere or change anything. Whatever thing you create here is on its own. Whatever thing you are doing here is also different from what is here. It won't update the value or change anything. But if you are using like a field value, immediately you come down here and start changing those, like if we're not using a class this thing, immediately you start changing these values, it's overrides whatever thing that you have here. Once this line of code is finished running, it overrides anything that is running that is here, that was here initially. So, and that's not the behavior we want. We don't want when Toyota builds a car, it means there is no more Tesla cars. You know, we want, everybody should have their own thing going. So if we run this guy, there is something wonderful that it will do. Did anyone drop, or was it me? Okay. So it does something wonderful. This is called the so it creates, this is called we are calling the car here, right? If you notice the code or the distance is different. So it just creates an object in the memory of your application. Even though we are saying that it should print out, we were expecting it to have all this information. But in memory, in the memory of the system, what we are calling is this, the address in memory of the system. We are only pointing to this address. So this one belongs to the first one, Tesla. This other one belongs to this second one. That's because in our code here, we are not overriding the string, what's it called again? To string, yes, it's called to string. So we are not overriding it. The only thing we can do here is maybe do a get. For Toyota now, we can say get name or get brand. If we print it, it will give us the brand of the Toyota, but we don't have all the informations. You see, he gave us the brand of the Toyota, but the behavior we wanted is to have all the information that is associated with this Toyota. For us to do that, we need to override the toString method that the class has. Or yeah, so let's generate toString. So this way, when you run this code now, it gives you the string messages or the string values that we are looking for. You see now, this. So in memory, in how do I say this now? In memory, Java has its own string way of doing string of returning string, which is this thing that we saw earlier. What's it called? The string in the memory address. That is how it's stored. That is what it stores the car as. But for us to be able to get the value that we are looking for, the name, the whatever thing that is passed there, we need to override the one that Java already has. So we need to override it and pass our own value. Remember when we were talking about methods, we talked about method overriding. method overriding is when you want to override something and give it your own definition. That is what we just did here. We are overriding what Java has, the definition Java has given to its to an object, and saying no, when we call this object, we want to return, we want to see all these things. Does it make sense? Hello? Is anyone here? Okay.
Yes, it
Oh,
does.
all right.
Yes,
So
it does. Well, I
do
have
you
a
have,
okay.
yeah, please go ahead.
Yeah, my question is, at every point in time we're working with, maybe we're creating objects from a
I didn't
particular
hear, I
class,
didn't hear.
we
Can you,
have to,
can you start again?
can you hear me?
Yeah, yeah.
Hello?
Yeah, I can hear you.
Okay, so my question is, so for every time one is creating a class and then having to create an object from a class, we need to always override the memory address. Like it's something we have to constantly do, or it depends on the operation.
It depends on use case, actually. It's not something you have to
Okay.
constantly do. Yeah. Then another thing
Okay.
too, when we go into, you don't have to manually do all these things. Yeah, that's true. That reminds me. You don't have to manually do all these things. When we go into Spring Boot and all, you will see a way that we can just use one annotation to remove all these codes you are seeing here, all these codes till here. You just use one annotation and have it there. Like you just use one. If I go back here now, it will throw an error. But if you are using something called Lombok, it will just handle all this. They call it no, it's not Pojo. It's not what is it called? I've forgotten the time that it's called. It just all these things that is not needed, so to say, it will just handle it for you.
Oh, okay.
Yeah, you just
Okay.
come here, do at data. We don't have Lombok here. You just come here, do at data, and it populates all those things. Let me show you from this guy. So oh, we are using getter and setter here. Let me see at data. So you see, I am not doing anything. I just defined all the informations I need in my class and use that data. And if you see here, this class, this thing has a setter and a getter. See here, I am calling the getter of this class. I'm calling the getter somewhere. And the same way I am also using,
Okay.
I don't need to see also the setter here. I am calling it, but I didn't define it here. It's simply because I
Okay.
this annotation here. So
Mm. Mm. Thank you.
yeah, when we get to Spring Boot and all, we'll explore all those. But for now, we'll make do with this. Does anyone have any other question? Then there's another way we can actually do this. Like if the only this thing we have is to print the information, there's another way to do this without having to override this guy. We can just define a method that public void and say display info, display car info or something. Car info. What we just want to do is S out system, the name, space. Is it space? The name, then do this guy. Yeah, this is what I. So this way, you will now have to, when you are printing this guy, you now have to do dot display. You call the display method. You don't even need to actually do this guy here, Seth. You don't need to even have this here because the display method will just print everything. Why is it taking so long? Yeah. So you remember, because we've removed the to string this thing that we were overriding. This guy now, the default listing, he went back to default listing. The other guy, we are calling the display method. It prints, it gives us all the information. The name is Toyota, which is what we can confirm here. The color is black, all those informations, it gives us that. But for Tesla, because we are not calling the display method on Tesla, it's giving us the object's address as the information. Does it make sense, or did it confuse you for that? I don't know. I hope it didn't confuse you for that. Did it confuse you?
Yes, sir.
Eh?
For me, no. I said no.
Oh, okay. Oh, okay. Okay.
Can you hear me? Okay.
Yeah, I can hear you. Okay, so number one thing you should know about this guy, constructor. Let's remove it before it starts shouting when we comment it. We can decide, of course, Java takes care of it under the hood for us, but we can decide to also have it. Number one, it doesn't have return type, and it must be the same name with the class you're working with. It doesn't have return type. You see here, there's no return type. This one has a return type. This other guy has a return type. I think, yeah, we have integer here. It has a return type. But this one doesn't have a return type. It's not a method, right? It's called, that's why it's called a constructor. It's just used to initialize an object or to pass values when initializing an object. What if it's used for initializing an object, but if we now pass informations, values here, of course, it will now demand that we also pass those values. That's one thing that we need to know. So let's briefly just run through the 4 pillars of OOP, and then maybe in our subsequent classes, because this is not everything that we're going to learn about classes and objects. In our subsequent classes, I would show examples of how we can use them in our code to make our code better, right? Does it make sense?
Yes, sir.
Okay, so I think most of us should, if we have basic knowledge of programming, we should know the pillars of OOP. So pillars of OOP is number 1, abstraction. Number 2, encapsulation, right? Then we also have inheritance. Then we also have polymorphism. So abstraction is how we hide things, right? Or not hide, anyways. Encapsulation is how we hide things. Abstraction is how we define things. Like, we don't make them to be concrete or tightly coupled. Yes, we don't make them to be tightly coupled with each other. We use it to I want to define something, and then the name of the same thing. I wanted to say we use it to abstract informations, but we use it to define something, define a method mostly. Okay, we use it to define a method, and even classes too, without having to write the implementation of those things. This thing is used for hiding the implementation or the details of the method that we are exposing. So we want to define a method that says, okay, let's say something like for our car now, we want to hide the informations of how a car stops. We can use an abstract method to do that kind of implementation. People don't know how it stops. You don't know how your brake and every details of the brake of a car works. All you know is that when you want to stop your car, you step on the brake, it stops. All the informations of how the engine is working, how all these ones it's abstracted from you. You don't even need that information. It's the same thing for people when they want to use your code. They don't want to know how a method works in your code. They can just use it somewhere and say, oh, you've written this thing. They don't even have to go through the step-by-step of how they just use it. They don't care about what is happening, right? That's like the best definition I can give for abstraction now. Maybe I can think of others. Then encapsulation is what we are doing here. We are using it to hide our data. We are using it to say, okay, oh, don't initiate a level of security into our system. We don't want everybody to have access to it, so we are using it to wrap our this thing. So inheritance is obviously inheritance is when a class, okay, let's say we want to, inheritance is when a class is inheriting from another class. A child class is depending on a parent class or a subclass. So a subclass is depending on a parent class rather. So let's take, for example, in our car instance now, let's say for example, everything is, a car is like a vehicle. So a vehicle should be the parent class of our car, right? Because a vehicle can be a car, it can be a bicycle, it can be anything. So we can now say, okay, what are the informations that is generic for every car or every this thing? We'll use those, we'll copy those informations out from this place, put it in a vehicle. So when we define like something like a bicycle now, bicycle, is that the spelling? I know it's not. Anyways, we can just say extends then vehicle. It comes with all the information that is needed, that is predefined here. Then we can now define the ones that is specific to a bicycle. Does it make sense? Hello?
I'm sorry, yes, it does.
Okay, yeah. So the same thing, a truck is also a type of a vehicle. We can define a truck. There are some things that is in a truck that is also not in a normal car that everybody drives. Oh, if you're a vehicle, if you're a car or something, get your basic information from a vehicle. The same thing with bicycle and the rest. We would go into more details of these guys, but this means that this guy is tightly coupled to vehicle, and that is one of the things. If you're writing a clean code, that's one of the things that you are told to avoid.
Hello, sir. I can't hear you. I don't know. Okay. I can hear you now.
Oh, okay. You can't hear me.
And you were saying something about tightly coupled, and then you tripped off.
Okay. So I was saying that this guy now is tightly coupled. This bicycle is tightly coupled to the vehicle. So if you're writing a clean code, it's advised that you don't write code that is too tightly coupled. So by all means necessary, it is advised you use you use instead of this inheritance, you use composition. We'll get into that later. You use composition instead of using inheritance. So we'll discuss what composition is later on in our discussion of classes and objects. Then the next one too, I think we've covered this. Polymorphism is how you make your code to pick up a behavior in runtime, right? So you have multiple. Okay, for example, there's in our workplace, there's a code that we wrote on runtime. It's used that instance of, yes, exactly. That's instance of is sort of, okay, when you are running, compare this thing. If whatever, I remember I mentioned instance of to you guys, Abby, when we're talking about I think is it loops or conditional statements? I can't remember which of them. I think, did I mention it to you guys, please? Or I don't want to just assume that I did.
Yeah, I think you mentioned something on polymorphism in the last.
Oh, okay.
class.
Yeah. See it here. I mentioned
Yes,
instance of. I
yes,
don't think I showed you guys how it's utilized. So now, instance of, you are comparing a data that is coming in. Okay, does this data belongs to, maybe you are comparing different kind of, if it's a car, do something, do this. If it's a vehicle, do this other one. If it's a bicycle, do this other thing. If it's what else again, a truck or a bus, just do this, do something else. That, so polymorphism can give us that kind of behavior without us doing that if instance of check. So polymorphism can make the code. We can write one code instead of doing all those checks. We will write one code, but polymorphism will now, the code will now check. Okay, when it's coming on its own, it will check this thing that is coming. Is it type of a car, and performs the instruction that is only dedicated to a car. It also checks for other ones. We will get into all these details. I just wanted you to maybe know about them and then read about them. That's the main purpose of me mentioning it in this class, so you get familiar with it. So we'll talk about them in much more details in subsequent classes. Is there any question? Let me stop recording. Any other questions, guys? Okay.
Yeah.
All right. I take it that I've been a great teacher.
Oh, you have. Okay, sir, please.